Hello and welcome to another innovator interview on sustainability in your ear, the Earth911 podcast. I'm Mitch Ratcliffe. Welcome to the show. You know, today we have Leslie Field, Dr. Leslie Field, Ph.D., who is the founder and CEO of Ice911. Welcome to the show, Leslie. It's a pleasure to have you here.
Thank you. It's wonderful to be here.
Well, you have such an amazing background. You've worked for HP and Agilent and Chevron. You've been working in the semiconductor industry where you have 54 patents. It's what brought you to ICE and to becoming the director of the Center for Climate Restoration's Polar Restoration Action Group in addition to Ice911.
Well, it started with a movie.
Really?
I saw the Inconvenient Truth movie, the first one that Al Gore made in 2006. And at that time, I had two young kids. They were only 6 and 10 years old. And having watched that movie and seen just how real, it was the first time I really got it, that climate change was real. The experts weren't disagreeing about it. It was there. And it was going to be a big factor in my own kids' lifetimes. And that, as I say, that was the wake-up call of, wow, I'd better do something about that.
Well, let's talk about how do you see the impact on your children's lives of ICE or anybody? How does anybody recognize this in their backyard?
Yeah. So here in California, for instance, there's now a direct line connection in published peer-reviewed literature about how the destabilization of the jet stream, basically the polar vortex, the whole change of what's happening up there, because we no longer have that reliably cold spot up in the Arctic compared to the rest of the world. That stabilizing force has led to this change in weather, and so there's now peer-reviewed publications out there linking the wildfires in California, which we're suffering through yet another one here. We don't have the flames burning in our backyard, thank God, but we've got the smoke here reminding us of, our neighbors a few hundred miles away who are burning. So that's one of the effects.
Yeah, and you have smoke that is going 8 miles into the atmosphere because these fires are much hotter than previous fires as well. That, of course, is contributing to feedback that is further warming the environment. And of course, I think that's one of the problems people have in trying to conceive the relationship of Arctic ice to their daily lives, just as they don't know how to imagine the fact that there are megatons or gigatons of carbon in the atmosphere that you just don't see, and yet it is there. So what is the state of ice today? How let me put it this way, how bad is it?
Well, it's bad. One thing that it surprised me when I started getting into this a dozen years ago was that I could show videos of satellite imagery looking down at the Arctic of ice melt over the last few decades. And these tend to show the age of sea ice, what's remaining, kind of correlates with the volume of it, not just the area. And this would be a surprise even to experts in climate. It wasn't well publicized. And so it's no surprise that it's, something that most people don't go about their daily lives thinking about. I mean, I've always been concerned about climate since I was a kid. I love the outdoors and hiking in nature and all of that, and the first Earth Day, all of that. But when I saw that movie, it was like, wait, it's here now. It's worse than I'm hearing. And so the ice at this point has disappeared. Over 3/4 of the ice in the Arctic is now gone over just the last few decades. Bright reflective ice especially is almost completely gone at times of the year. And what that means, now let's start that over. That wasn't quite right.
Okay.
Just back a sentence or two. But bright reflective ice in the Arctic is particularly in low supply. And the problem is that it's another one of those feedback loops you mentioned. And in fact, that's what first grabbed my attention about ice, was the ice albedo feedback effect that was mentioned in the Inconvenient Truth movie. What it means is the more ice melts, the faster what remains melts. And the reason is that you've got a smaller amount of ice, that's not guarding itself anymore, right? Think of a tiny ice cube, out there in the warm, and think of a much larger chunk of ice. The larger chunk is going to last longer. The ocean's getting warmer, all that. With the loss of so much ice now, and with not much multi-year ice left, we do refreeze the Arctic. We're still cold enough to refreeze in the winter. So that's the good news. The bad news is what refreezes is as first-year ice, and first-year ice isn't nearly as reflective as multi-year ice.
So what is the benefit? Explain to our listeners the benefit of reflective ice to the planet.
Yeah, thank you. And then I'll explain why thin ice, why not multi-year ice is so hard. So reflective ice up in the Arctic has had this beautiful function over years of reflecting most of the summer incoming sunlight that shines up there 24 hours a day. And so when you get rid of that white T-shirt, basically, that part of the planet has been wearing on hot summer days, you now are wearing your black T-shirt or your bare skin, and you're not reflecting the sunlight away, you're absorbing it. And that's what accelerates things so much. So when you've lost your bright reflective ice and you're growing back thin ice that's rather perfect, and rather perfect means there are not very many opportunities to reflect the incoming sunlight. A lot of it's going straight through to the ocean below. Your ice doesn't last very long, that thin ice, and then the ocean is picking up more and more heat. So that's bright reflective ice has been our guardian, though we knew it not, which is
we often don't recognize until too late.
Yep. So that's the problem that we're trying to solve. This one side effect of climate change, this one outcome of rising CO2 levels and a warming Earth in itself is now a primary cause of further climate devastation. It's destabilized the jet stream, is just causing a host of other harms, rising sea levels. When you've got the sea ice gone near Greenland, you've got a warmer atmosphere that is now coming over Greenland and helping it to melt, so further accelerating rising sea levels. There's just this host of harms, including, as you say, our very own backyard of wildfires and droughts, and in the rest of the world, much more severe storms. It's not that there are far more storms, it's that more of them are record-breaking in severity because this entire weather pattern has shifted.
Right. Now, so a lot of people became aware of your project because of a recent Vice program on HBO, which was fascinating. And even though I had been aware of your work, it was striking to see it. Tell us about reflective sand and your proposed solution to, or at least your solution to kickstart the refreezing of the Arctic.
Right. So, again, going back to realizing somebody better do something about climate change, and looking at my kids and looking around at what was out there, what I thought we really should need, and what I thought I would keep very quiet about to start with, was just developing a backup plan I hoped we'd never need of, let's work on that ice. And the insight I had, fortunately, was a way to frame this as something that I could address. So I have a lot of background in materials along the way as I've done my work in school and in industry. And I just thought, what if we could replace that lost functionality of reflective ice with some safe material? So that became the quest. And I've tried a whole lot. I've been at this for a dozen years, largely as a volunteer in the beginning, now last several years as this is the day job. And I have gone through a lot of materials, sort of thinking aloud with whatever test area I could have, starting out in laboratory tests mostly, of would this material reflect sunlight? Would it be harmless? Would it actually cool things underneath, or would it heat it? And so you start out, I'm an inventor, so I'm very comfortable with coming up with the ridiculous ideas first. And, I'm very comfortable with that. As long as you keep going until you actually make it work and you keep applying reason to it after that initial inspiration, which, at least half the time it's a dumb inspiration. But, as you move along, you get it towards what's going to work. So I've tried things like plastics. I think everybody thinks about plastics. They're ubiquitous. You can get them white, what could go wrong? But the problem with that, for instance, is that you're basically remaking your pool cover. So you're keeping things warm underneath. It's like you're, right? And so that's a bad idea. It's a bad idea for so many reasons, right? It will break down eventually and give you plastics in your entire food chain, your entire ocean, your entire planet. We've learned that's a terrible idea. One of the things I particularly didn't want was something that would pick up oil-based pollutants and then get in the food chain. So those are hydrophobic, plastics are. So having experimented with that a little bit, I thought I want the anti-plastic. And the anti-plastic led me to glass. It's like, well, glass is hydrophilic. Glass is fundamentally sand. Silica, gee whiz, that's something we've all evolved with. That's probably a lot safer. It won't tend to pick up oil-based pollutants. It's wettable, so you don't suppress evaporative cooling, so things will stay cooler underneath. And I started running experiments with various forms of, floating sand, as we call it. Hollow glass microspheres is one of the kinds that we use, and that's the more technical term. And by gum, it can make water underneath much cooler, and it turns out it can, as I had hoped, preserve ice and snow underneath it. So it's a successful material. And what is really gratifying is, as hoped, I wanted the gentlest reboot in the most natural way with the least material you could add. I mean, if you're going to think about making a change, you want something that's going to be as gentle, reversible, localized, safe as you can. First, do no harm is a very important tenet. And so what we found is that with layers of something like, a few hairs width thick of this small, round, white, floating sand-like material, basically silica, that you can preserve ice. You can make it last, 20%, 30% longer. And that sounds very small. But and we've done years of field testing and developing instrumentation and all them to be able to monitor this and, ecotoxicological testing to make sure it's safe. But the exciting thing this year, really exciting for us, was that we got to team with an expert team of climate modelers. And they got to show that by modeling this, that we can actually not just slow the melt and make things less bad for a while, right? Which really was the more humble aim to start with. We can actually restore Arctic ice. And that was, wow. That coming with the realization that at this point, as much climate harm as we've had from all the CO2 excess in the atmosphere, this is contributing another half again as much. So when you think about that, and you think about with the ice loss that's gone right now, we have lost, we're contributing, depending which expert you're listening to, from the ice and snow lost in the Arctic, we're contributing a quarter to a half of all global temperature rises coming from the loss of these reflective areas in the Arctic. You say, this looks to us like the largest single addressable, reversible, safe lever on climate change there is. And that's a profound realization. And, the fruits of a dozen years of hard work, including 3 years of field testing in the Arctic, as you said.
And that's incredible. And so one of the things that we've talked with a number of different folks about forms of climate restoration and ice restoration, such as Peter Fikowski from the Healthy Climate Alliance. Yeah. Do you see reflective sand as a part of a multifaceted strategy, or is this something that we can deploy and that would take care of it?
Oh, so yeah, that's such an important question. And this is part of why I kept quiet about this work for a long time. You don't want work like this to become the excuse for continuing down the path that got us here in the first place. You don't want to be the excuse for more coal mines or, gas guzzlers or, just this careless, when you're thinking about the long-term consequences, careless sort of lifestyle choices. You don't want to be the excuse for that because in the end we'd be worse off, right? And so this is something that is meant to go along with all that other hard and responsible work of, getting making the sustainable fuel choices, making the sustainable energy choices. Geez, conservation, right? That's job one to start.
Mm-hmm.
And just moving on to the kind of carbon-free, CO2-free, energy economy that we know we need. That has to happen too. But I do think that with the tipping points in the Arctic, this may be one of the first things you want to do, because the ice experts, actually through Peter Fiakowski and the Center for Climate Restoration, Healthy Climate Alliance, I got to be in touch with a lot of the Arctic experts, polar experts. I'd contacted a bunch of them over the years myself, but we've got a few more now. And we have this consensus view now that they articulate. You mentioned I'm the director of PRAG, the Polar Restoration Action Group. The consensus view from the climate science modelers up there, Arctic guys, are that we will be ice-free in the summers by 2030, plus or minus 10 years. And if you think about that, minus 10 years, that's 2020. That's like tomorrow. Yeah. And that's an urgent problem.
So let me ask you, there are a lot of folks listening, maybe thinking about their careers and what they can do to help. For a young person looking at their choices in life and is getting involved, as you have, in climate science and climate restoration based on your experience in industry and material science, is that an opportunity, do you think, or is that a continuing to be a challenging way to make a living?
I think it's one of the biggest and most simultaneously horrifying and wonderful opportunities you could ever have. I've known since I was young, like about 10 years old, that I wanted to be an inventor. And being an engineer has been a wonderful way to do that and to solve real problems. This is the big one. I teach a class. I've been volunteering in classrooms ever since I had kids, all the way through the K-12 years. And they're now off to college. But I've also been teaching at Stanford this is my 9th time teaching a class I started 9 years ago, every fall on engineering, entrepreneurship, and climate change. And what I'm trying to do there, and I welcome auditors, and in fact, we get some high school kids coming in and auditing, and certainly undergrads, grad students, and community members come on by on Tuesday afternoons in the fall. What I've tried to craft there is a crash course for, hey, if you've just realized you want to work in climate, how do you get into that? What are some of the things you want to know? And because it's offered out of the electrical engineering department, so you might think it's all jargon, but I actually get a very interdisciplinary crew of people coming to guest lecture with me. I take the first and last lecture, to frame the class and talk about my own adventures here with Ice911. But the other 8 lectures are from a broad range of disciplines. Policy and finance, and even just straightforward exploring, the Arctic and the Antarctic, firsthand observations, and then a variety of entrepreneurs. We've got a guy from NASA and a guy from a clean tech open startup this week. Next week, we're going to have the co-founders of Tesla and Kat Taylor of the Beneficial Bank and the Tomcat Ranch, the sustainable ranching. So we have a wide variety. And because we have such a wide variety of lecturers and students, everybody has to speak in English, not jargon. So it's something that a lot of auditors come by and just keep coming by. So that's one way to try to illustrate for folks that there's a variety of ways to get into this. And what I try to articulate at the beginning and the end of the class particularly are that we really need, to solve climate, we really need strong policies. We really need good science so we know what on earth it is that we solve. I mean, you hear me deferring to the climate scientists of when do you think the ice is going to be gone by? I don't pretend to have that expertise. I just listen to them a lot, right? And so we need those, and we need the guys who are going to come in and solve the problems. And, in my view, that's the engineers. We need a host of other folks as well, social media, learning to...
Well, translating between these various fields of expertise and everyday people is so critically important. And the project of the century, it's really the project of our species' survival and future prosperity, is such an important thing for young people and older people. My kids are off to college too, and I'm working on Earth911 now as a result. So it's incredibly compelling undertaking. A lot of people just think that it isn't a career, that it's a hobby, and it's what you're saying is that is changing as the economy changes. We'll recognize the value of these contributions, and in some ways, we don't even begin to comprehend how invaluable they are at this point, but we'll get there.
Our guest lecturer last week is the recently retired Deputy Director of NASA Ames down here, and he drove the building of the most sustainable building in the entire federal government. Mm-hmm. And Dr. Steve Zornitzer, also just joined our governing board at Ice911. So we are
congratulations.
We feel very lucky about that. But he was so articulate as he went through for the class so many of the features in this really sustainable building that was, thought mm-hmm. through from the ground up. He was so articulate about the many, many job opportunities that are there for building things the right way for the future, for now. It was beautiful.
That building, reading about that building is probably the most practical example of the many different ways that design can be changed, but also the many different roles in managing the environment of a building. Mm-hmm. And it's a fascinating because it's self-cooling and self-heating. It opens to allow air through. In a lot of ways, we've designed an environment in the NASA Ames building that is the ideal managed human environment because it is not taking away from the climate. It is contributing to it, and that's really, we need more projects like that. So now, Ice911 is a donation-supported organization.
That's right.
How can people get involved, and what would you be doing with their donations? Tell us about that.
Yeah, perfect. So what we're working to do, so we are a nonprofit, and since mm-hmm. we think the key leverage points on climate are going to be on sea ice, we're actually talking with all the regulatory bodies that you would think of to be able to work on sea ice. We really, we know that you need governance and you need permits to do this sort of thing well, right? Some external review besides yourselves seems essential. And we have learned from the IMO, the UN's International Maritime Organization, that, the London Convention, London Protocol folks, that because we're a nonprofit, the path to permitting and governance for such work is going to be far easier than were we a for-profit. And that's really nice to know, that this was a good choice. We benefit from, and we're not against having for-profit spin-outs in other areas. Technologies can be used widely. And, I'm an inventor for a long time from an industrial R&D, so we have that as a possibility going out there. But our focus for a while is going to be this nonprofit work of conserving and restoring Arctic ice. Over the next few years, what we're using donations from individuals, from foundations to do, and we've really been getting that ramped up lately as people really get that this is important. So that's very gratifying. The more we can get in, the faster we can do this job of scaling up the technology. We have another, depending how fast the donations come in, we have another 1 to 3 years to answer all the remaining R&D questions, get the rest of the climate modeling done so we know where the exact most strategic areas that we want to make rather small deployments to have these very leveraged impacts on slowing ice loss and then rebuilding ice. So we have a great deal of work to do there. We have our field deployment techniques worked out for lake ice that we've been working on, but we need to get that worked out on sea ice. We have phenomenal ideas on that, but we need to actually get them down to testing, to practical application. So for another $3 to $10 million, depending how fast we want to go per year for the next 1 to 3 years, we can get the rest of that R&D work done. And then we start scaling up. We'll start with a 1% is what I'd like to do. 1% of what we think a full area is. Full area is something like 100,000 square kilometers. It's like 0.5% of the area of the Arctic is what we're aiming for as a key strategic deployment. And I want to start with 1% of that and look at that for a season and make sure we don't have any undue impact anywhere. Then the following years will scale up to 10%, then go to the full size. And at that point, full size again being 0.5% of the area of the Arctic, at that point we are restoring Arctic ice. And so it's within, something like 1 to 6 years, depending how quickly we can get things, fundraised, permitted, and done, that we're restoring Arctic ice. And that's exciting.
So every dollar that people are contributing today is really going to have a direct impact on that success. That's phenomenal and a great opportunity for listeners out there if you want to make a difference to jump in. Now, the other thing I wanted to talk about is you have a very attractive shirt, and it has a somewhat familiar phrase on it. Where did you get the idea for "Make the Arctic Great Again"?
I have to credit my colleague Roman Deca. He is a former auditor of mine, actually, from my class. So here's another benefit from teaching this class, and happens to have this, this other sense of humor and graphical sense to say, we should make T-shirts like this.
I think everybody ought to be out wearing this one. It's the perfect complement to the dialogue in our country. It's a blue shirt, says "Make the Arctic Great Again." You also have a hat.
We do,
and the money does go, of course, to supporting the organization. So, and we'll have a link on the site to that. But I think this is a great shirt and a perfect Christmas gift for anybody who would love to be part of the greater dialogue about restoring ice.
Thank you. And we also have a need, if people have the right connections to the major, individual donors or foundations that will really get our work. Warm introductions help a lot, and we have a need for a variety of skills. So check out the website, check out how to see us on social media and all. Join our mailing list and write us a note if you would like to get involved.
Well, we will be encouraging people to do that. Ice911 will be, folks, will be contributing a regular article about sea ice to Earth911 as well. So you'll be seeing them on our pages more frequently. And each time you see them, we'll be offering you the opportunity to support the organization. So do check it out. Leslie, thank you very much for your time today. What final words would you leave with folks as they think about their choices and their relationship to ice, Arctic ice?
Yeah, I guess I've got maybe 3 parting points here. One is the question that haunted me and made me start this, and that was looking at my kids, looking at this situation and thinking something I'd learned from a wonderful mentor when I was working at HP Labs, and it was the, if not me, who? If not now, when? If you drink in a situation like this that you know is going to affect people you care about, including yourself, that's a question that can really haunt your dreams.
Leslie?
Yes. Hello?
You just went quiet as you said, if you think about people you care about. I lost you right there.
Oh, interesting. Well, I'll try again. If you think about people you care about, or even yourself, right, and you ask yourself a question like this, then it can end up haunting your dreams, and it can end up causing you to do some amazing things. So if not me, who? If not now, when is a good one. I would say also I meet a lot of people who tell me, oh, I'm not an engineer. I really can't contribute to this. I don't know what I can do to help. And that's actually far from the truth. There are so many skills we need. And, some of our most powerful people outreaching for fundraising, to foundations and individuals in the right way are people with a not very technical background, but who are really, really sharp and passionate about it. So don't assume you can't help is something I think really important to think about. And then I'd go back to that point I made before. This seems to be one of the things that you could do now, supporting this, that could have the greatest positive and safe impact as soon as possible. And that's a really, I've been slow to come to that realization. So it isn't that I've just got this ego that demands, no, mine's the best. No, I've been rather slow to realize this really, as far as we can tell, this is the truth, that this is one of the most important things going right now. And so,
and we can make a difference.
Yeah, you can make a difference. And what a wonderful thing to wake up to,
Yeah, definitely. Well, Leslie Field, founder and CEO of Ice9, thanks so much for joining us on Earth911 today. We'll be talking to you again, I hope.
Oh, Mitch, thank you so much. This was a real privilege. Thanks a lot.
Well, folks, that was Leslie Field, and we'll be featuring Ice911 articles on Earth911. Keep an eye out for them. And, of course, tune in for the next Sustainability in Your Ear Innovator interview. This is Mitch Ratcliffe, Earth911, and we'll be back with you soon. Take care.